So this is a couple of questions from exercise 4C. I've already started to work through this. The problem with this question is initially we have two fractions here. And to try and get rid of the fractions, as long as we times each term by the same thing, it doesn't change the equation at all. So to get rid of my x plus 1, I times the first term by x plus 1, the second term by x plus 1, and the third term by x plus 1. But by doing that, the x plus 1 over the x plus 1 will cancel. Now I also had an x minus 3 as a denominator, so I times each term by x minus 3, and then I get rid of my denominator because x minus 3 over x minus 3 will cancel. Now once I've got to that stage, then I can start solving this equation. So 12 times x is 12x, 12 times negative 3 is negative 36. We've got to be very careful on this next step here because we've got a negative here and we're also going to distribute. So negative 10 times x is negative 10x, and negative 10 times by 1 is negative 10. Now on the right hand side here, we can either distribute and then do FOIL, or we can do FOIL and then distribute. I personally prefer to do FOIL first, so that's what I did here. And I collected terms together here, x times negative 3 plus 1 times x. Then I can actually distribute the negative 3. And I didn't actually do anything with the left hand side at all at this stage. But then I can obviously collect terms here as well. So 12x take away 10x is 2x, and negative 36 take away 10 is negative 46. Now, as it's quadratic, I want to set this equal to 0. I always prefer a positive x squared, so I'm going to bring this to the other side and make it positive 3x squared. I'm also going to subtract 6x on both sides, and I'm also going to subtract 9 from both sides. And then once we get it equal to 0, then we should actually be able to work out what this question is. So let me do a little bit more work on this. Once we've got it to this step, we should be able to do sliding glide, or we can possibly figure out what the two numbers are going to be. For 55, I can see that that's 11 and 5. And also 11 take away 5 gives me 4, so that's probably going to be helpful for this one. So 3 times 5 is 15, and then take away, oh, I need to make this one negative. Negative 15 plus 11 will give me negative 4, and then equals 0. And then either 3x plus 11 equals 0, which means 3x equals negative 11, and therefore x equals a negative 11 over 3. Or alternately, x minus 5 is 0, and then if I add 5 to both sides, x would equal 5. So that would finish off that question quite nicely. Now for question 6e, we got something that is a cube root this time. So this is x to the power of 2/3, and with this being a cube root also this is x to the power of 1/3. And notice this is twice the value, so 2/3 is double what 1/3 is. So what I can say is if I do x to the 1/3 times by x to the 1/3, that's going to give me x to the 2/3. And then I've just got to figure out what the two numbers are going to be. So times to make negative 6 and subtract to make negative 1. So negative 3 and positive 2 works. And then now it's equal to 0. Either the first one is 0 or the second one is 0. I'm going to rewrite that 1/3 as a radical. So like that. And then I can bring things to the other side. So I'm going to add 3 to both sides. Do a cube root. Do a cube to get rid of the cube root. So 27 would be one solution to this problem. When I do the other one, instead of adding 2, subtract 2, and then instead of doing a cube root, I do a cube, and negative 2 cubed is negative 8. Now, a lot of people, having just done questions with radicals, when you have the square root of something that's negative, we're going to say it's no solution right now. We're not going to worry about imaginary solutions. And then they do the same thing when they see it's a cube root, but the cube root works perfectly okay. So that one's not a problem. If you do the cube root of negative 8, it is negative 2, because negative 2 times negative 2 times negative 2 is negative 8. If you're not sure, you can always plug it back into the original as well, just to make sure you do end up with 0.